Hi folks, we're in Module 2 again, looking at the Novice problem solutions. Now we're going to look at problems 4 through 6. So let's get out of this PowerPoint and into our data. Here's practice problem 4. In this section, we're beginning to look at the way we create a relative and cumulative frequency, all leading towards something called Pareto analysis. We're always trying to prioritize things in the world of business and enterprise, and Pareto analysis is how we do that. So we take the things that are most significant and most important, and we can make some statements about those things. We've got some data here, port data on the number of 40-foot containers, the number of tons. These are long tons. The shipper, the port, various types of information for, looks like 78 observations. So let's do some analysis here. The problem says that the TSA official that organized the meeting makes a statement that interests you. He speculates that the top 15 observations, 1 through 15 now, that they're sorted in terms of tons of cargo. This particular column represents very close to 50% of the total tons. So we need to find out what the total tons are. Total tons are down here. Looks like 67,605,100. We can create a relative frequency column over here, and we do so by dividing C3, which is the tons, by the total. Notice how we've got an absolute address here, so we can just copy this guy down and do the proper calculation by keeping the absolute value of that we see in the bottom total. So let's now fill that in. We get the relative frequency. The cumulative frequency, of course, is the frequency in a cell plus what was above it. In the first one, there's nothing above it. In this one, it's F4, which is what we have in this cell plus what we previously had in this cell. So this formula also allows us to copy it down and to do that properly because we want a relative addressing here. There's our, again, I like that gold color, so I'm going to put it back in. So let's see if we can answer the questions. He said that the first 15 observations should lead to the 50% of the values. And what we see here is that the first 15 observations represent 28%, 28.45%. So obviously the answer to the first part, is he right, is no. And since I want to continue the problem, I say, well, if he's wrong, what is it? Well, we look down here in this column until we get to about 50%, and we see the first 30 observations are what leads to approximately 50% of the tonnage. So there we are, 30. Again, Pareto analysis would be something we're going to be doing a lot with, and it's very useful in terms of making statements about priorities. In this problem, we're going to create a frequency distribution for 40-foot containers, and we're going to use the dot plot graph in Minitab. So I'm going to have to grab the 40-foot container data. I'm going to copy that. I'm going to go to Minitab. I've already inserted it. So there it is. I don't have to reinsert it. Maybe I could if I wanted to. It didn't like some of the verbiage in there, so we can call this 40-foot CNTR. Now let's create a dot plot. Let's go to graph. Let's go to dot plot. Dot plot's like a histogram kind of, except in a more primitive fashion. Here's a simple dot plot for one variable. Let's use it. Hit OK. Here's the value that I want to use. I'm going to get rid of this one that was there before. Put this in. Hit OK. And there's my dot plot. There it is. I can also make this bigger if I want. And I'm looking for the most frequently occurring value, which looks to be here, right? There are 1, 2, 3, 4, 5, 6, 7, 8, 9 values there in this bin. And the bin is between 27,500 and 28,500 from what we can see there when you point to it. So let me copy the graph. Let me go back to Excel. I'll paste it over here someplace. And there's our graph. And of course the answer is 9 observations in the bins 27,500 to 28,500. It's the largest number. That's the mode, the most frequently occurring element in the graph. Now let's go to problem 6. Problem 6, this is a very familiar diagram called a Pareto diagram. These are the relative values that accumulate through this red line, which is the cumulative frequency of these values. Here's the data that we have in this problem. Here's the total. These are RPN numbers, risk profile numbers. The larger the risk profile number, the greater the risk of some sort of failure of that type. One is fairly high, 78, 79, 50, and another one's 500. So let's create a relative frequency. The relative frequency is simply this value divided by the total. You can see that in the graph. I use absolute addressing and I can pull it down, and what I wind up with is a calculation that does the relative frequency. The cumulative frequency, as you know, is that value in this cell plus whatever value was in the cell above. There's nothing above, simply that. In this particular cell, it's X21, which is the value up above, and we add it to W22, and that gives us the value we want. Pull that down. The question is, how many of the sorted failure modes result in 50% of the cumulative relative frequency points, or cumulative frequency points? Well, the summation where we get to 50% is the first two. So 50% is contained in those first 2 points. That's about half of all the points that's allocated. The lowest is 500. What's the relative frequency of that? Does that represent? And the relative frequency, of course, is just that calculation. And there's the value, about 1.82%. So that particular failure mode is only going to occur 1.82% of the time. This failure mode is going to occur about 28% of the time. That's the largest value. Okay, and the first two cumulatively will lead to 50%. Okay, that's the end of this video. Next we'll see problems 7, 8, 9, and probably 10.